Do you believe in time travel? Every time we remember something from the past or imagine something that will happen in the future, we engage in mental time travel. Scientists discovered that whether we mentally travel back into the past or forward into the future, some of the same brain regions are activated. It is quite hard to understand the brilliance of major mathematical discoveries. On the one hand, they often appear as isolated flashes of brilliance, although in fact, they are culmination of work by many, often less able mathematicians over a long period. We may not prove you that we can really turn back time, but today allow us to somehow let you experience time travel as we go back in the 18th century of mathematics and discover the amazing things that mathematics has ever contributed over the past centuries. Introducing calculus. Did you know that the word calculus is a Latin word which means pebble? Romans used pebbles to do addition and subtraction on a counting board,
or also known as abacus. In the 18th century, the application of calculus has contributed a lot. Calculus was key to working with Newton's law of motion, which stimulated the Industrial Revolution. It is also central to quantum mechanics, which underpins the modern revolution in computers and communications.
The discovery of calculus is often attributed to two men, Isaac Newton and Gottfried Leibniz, who independently developed its foundations. While Newton considered variables changing with time, the interesting thing is that Newton developed calculus simply out of necessity, in order to have the tools he needed to solve problems in physics regarding celestial motion. Leibniz did similar work just a few years later independently of Newton, and it is actually his notation that we still use today. Isaac Newton changed the world we understand the universe. He revered his own lifetime, he discovered the laws of gravity and motion and invented calculus. He helped to shape our rational worldview. Calculus and its application. Calculus is a branch of mathematics that involves the study of rates of change. Before calculus was invented, all math was static. It could only help calculate objects that were perfectly still. But the universe is constantly moving and changing. No objects from the stars in space to subatomic particles or cells in the body are always at rest. Indeed, just about everything in the universe is constantly moving. Calculus helped to determine how particles, stars, and matter actually move and change in real time. Calculus is used in a multitude of fields that you wouldn't ordinarily think would make use of its concepts. Among them are physics, engineering, economics, statistics, and medicine. Calculus is also used in such disparate areas as space travel, as well as determining how medications interact with the body, and even how to build safer structures. You will understand why calculus is useful in so many areas if you know a bit about its history, as well as what it is designed to do and measure.
Now let us get to know the 18th century mathematicians.
Johann Carl Friedrich Gauss was a German mathematician, physicist, and astronomer. He was a child prodigy and started displaying signs of his brilliance as a toddler. He was just 3 when he corrected an error in his father's payroll calculations. As a 7-year-old, he dazzled his school teachers by quickly summing up the integers from 1 to 100. He was already criticizing Euclid's geometry by the time he was 12. He rose from humble origins to become one of the world's greatest minds. While still a teenager, Gauss became the first person to prove the law of the quadratic reciprocity. A few years later, using only a ruler and compass, he constructed a seven-sided polygon or heptadecagon. He also had deep interest in theoretical astronomy. Gauss made a prediction regarding the position of the planetoid Ceres, which was first discovered by astronomer Giuseppe Piazzi in 1800. According to Carl Friedrich Gauss, it is not knowledge, but the act of learning, not possession, but the act of getting there, which grants the greatest enjoyment. Charles Babbage. Charles Babbage, a brilliant polymath, is remembered today as the first man to build a computing machine. Charles was one of the 4 children born to Benjamin Babbage, a banking partner in Prides & Co. and the owner of the Bitton Estate in Teignmouth, and Betsy Plumley Babbage. He joined King Edward VI Grammar School in South Devon and then Homewood Academy under the Reverend Stephen Freeman. The school library inspired love with mathematics in him. He left the academy to be taught by 2 private tutors, a clergyman from Cambridge from whom he did not learn much, and the other an Oxford tutor who taught him the classics. In 1820, he helped establish the Astronomical Society, which asked Babbage and Herschel to improve the nautical almanac by removing the errors in the tables. This inspired in him the concept of mechanical computation. He published observations on the application of machinery to the computation of mathematical tables in 1822 in the Astronomical Society and constructed a small machine to compute the table of squares, known as the Beautiful Fragment. In 1823, following the Royal Society's recommendation, the British government assured to fund the difference engine, an automatic mechanical calculator designed to tabulate polynomial functions, but it could not be completed. In his second attempt, he designed a more complicated machine called the analytical engine, which was programmed using punch cards. The complex machine was designed for general computation, and this engine was continuously redesigned and developed from 1833 until his death. Apart from his computing machine, his brilliant mind achieved more. He designed an open submarine in which 4 people could survive for a couple of days. This polymath's friend and admirer, Ada Lovelace, is regarded as the world's first computer programmer because she prepared an algorithm designed to be executed by a machine. According to Charles Babbage, if I find no flaw in your reasoning about the analytical engine, I admire it. But you are aware that it rests entirely on the hypothesis that I care for the whole human race. Leonhard Euler. Leonhard Euler, the 18th century Swiss mathematician and physicist, is considered to be one of the greatest mathematicians of all time for the tremendous contributions he made to the field of pure mathematics. Many concepts of modern mathematics originated from the works of this eminent mathematician, whose works also spanned the fields of mechanics, fluid dynamics, optics, and astronomy. Euler's interest in mathematics stemmed from his childhood when his father would teach him the subject. As luck would have it, Johann Bernoulli, Europe's foremost mathematician of his time, was a friend of Leonhard's father, and the influence of this great mathematician on the young Leonhard was immense. Euler is the only mathematician to have had 2 numbers named after him. Euler's number in calculus with the symbol E approximately equal to 2.71828, and Euler-Mascheroni constant Greek alphabet gamma approximately equal to 0.57721. According to Leonard Euler, nothing takes place in the world whose meaning is not that of some maximum or minimum.
Baron John Baptiste Joseph Fourier.
Jean-Baptiste Joseph Fourier was a French mathematician and physicist born in the middle of 18th century in Auxerre, France. Coming from a humble background, he became an orphan by the time he was 10. At the age of 12, he entered military school run by Benedictine monks and became engrossed in mathematics. Later, he became a teacher at the same institution and joined the local Revolutionary Committee, a decision that almost cost him his head under the guillotine. Saved from the imminent death, he went back to teaching, but was soon picked by Napoleon to accompany him on his Egyptian expedition. On his return, he was made prefect of the Isir, a job he did exceedingly well. At the same time, he was given the charge of collating all the scientific and literary discoveries in Egypt, which was later published in a book form. However, he was more interested in academics, and after Napoleon's fall, he went back to Paris and immersed himself into mathematics. He was the first to discuss in a comprehensive manner the various aspects of the flow of heat in bodies. In his paper, he expressed the conduction of heat in two-dimensional objects in terms of the differential equations, basing his reasoning on Newton's law of cooling. The work later became the basis of another of his well-known work, Fourier series. And according to him, the profound study of nature is the most fertile source of mathematical discovery. Adrien Marie Legendre, a renowned French mathematician, holds a distinguished place in the field of mathematics. Having spent his early years in extensive research work, he has various theories to his credit. Legendre's contribution to the elliptical physics and mathematical analysis had been a guiding light for various other researchers in the similar field. He served as a professor at the famous Science Institute in Paris, wherein he also did his research and brought out publications simultaneously. His major areas of work cover elliptic functions, number theory, gravitational attractions, geodesy, calculus, and various other branches of mathematics. He has been honored by various titles, membership to commemorate his contributions in the field of mathematics and physics. He developed the least squares method, which has wide-ranging application in linear regression, signal processing, statistics, and curve fitting. He gave the concept of Legendre's transformation, which is used to go from the Lagrangian to the Hamiltonian formulation of classical mechanics. Legendre's transformation is also used in thermodynamics to obtain the enthalpy and Helmholtz and Gibbs energies from the internal energy. According to Legendre, all the truths of mathematics are linked to each other, and all means of discovering them are equally admissible. Pierre-Simon Laplace. Pierre-Simon Laplace was a French mathematician and astronomer who carried out remarkable studies regarding the stability of the solar system and is famously known as the French Newton. He also did pioneering work in mathematics regarding the theory of probability and statistics, which influenced a whole new generation of mathematicians. Born in a poor family, his education was financed by neighbors and he was sent to study theology at the age of 16. But He soon developed a keen interest in mathematics and was subsequently drawn to physics and astronomy. He served as a professor of mathematics for 7 years and also published several scientific papers alongside. Laplace successfully accounted for all observed deviations of the planets from their theoretical orbits by applying Sir Isaac Newton's theory of gravitation to the solar system. And he developed a conceptual view of evolutionary change in the structure of the solar system. He also demonstrated the usefulness of probability for interpreting scientific data and applied his own definition of probability to justify the fundamental mathematical manipulations. He restated and developed the nebular hypothesis of the origin of the solar system and also postulated the existence of black holes along the notion of gravitational collapse. He formulated Laplace equation and pioneered the Laplace transform, which appears in many branches of mathematical physics. Marquis de Condorcet. Marie-Jeanne Antoine Nicolas de Caritat was the name of a French philosopher, mathematician, and political scientist born in 1743.
He was given the title Marquis de Condorcet, a title of nobility, meaning that he was a part of the aristocracy in France in a period right before the French Revolution. The French Revolution began in 1789 when Condorcet was 46. In spite of his position in the aristocracy, Condorcet advocated equality among men and women and among all people of all races. He believed in a constitutional form of government and the rule of law instead of monarchy and aristocracy.
During his life, Condorcet made many contributions to both mathematics and political science. One contribution is the discovery of the paradox in voting with groups of voters. The paradox is now called the voting paradox of Condorcet. The Condorcet method, or the election method of selecting the candidate who would win in all pairings against each of the other candidates, was proposed by him. He was of liberal political views and believed in equal rights for everyone, regardless of race or gender. He became a campaigner for human rights and voiced his opinions, seeking equal rights for the blacks and women. He was excited about the French Revolution, in which he took an active interest and believed that bringing about political, economical, and social reforms were necessary to transform France. His political activities, however, led to his arrest, and he was later found dead in prison under mysterious circumstances. Daniel Bernoulli. Daniel Bernoulli was a Swiss mathematician and physicist who did pioneering work in the field of fluid dynamics and kinetic theory of gases. He investigated not only mathematics and physics, but also achieved considerable success in exploring other fields such as medicine, physiology, mechanics, astronomy, and oceanography. Born in a distinguished family of mathematicians, he was encouraged by his father to pursue a business career. After obtaining his Master of Arts degree, he studied medicine and was also privately tutored in mathematics by his father. Subsequently, he made a name for himself and was called to St. Petersburg, where he spent several fruitful years teaching mathematics. During this time, he wrote important texts on the theory of mechanics, including a first version of his famous treatise on hydrodynamics. Later, he served as a professor of anatomy and botany in Basel before being appointed to the chair of physics. There, he taught physics for the next 26 years and also produced several other excellent scientific works during his term. In one of his most remarkable works, Hydrodynamica, which was a milestone in the theory of the flowing behavior of liquids, he developed the theory of water mills, windmills, water pumps, and water propellers. But undoubtedly, his most significant contribution to sciences would be the Bernoulli theorem, which remains the general principle of hydrodynamics and aerodynamics and forms the basis of modern aviation. In 1723 to 24, he published one of his earliest mathematical works titled Mathematical Exercises. It focused on differential equations and the physics of flowing water. He also published numerous papers dealing with mechanics, which mainly focused on the problems connected with vibrating strings. He worked with Euler on elasticity as well as on the development of the Euler-Bernoulli beam equation. His most remarkable work was the Bernoulli's theorem related to the field of hydrodynamics. It states in effect that the total mechanical energy of the flowing fluid, comprising the energy associated with fluid pressure, the gravitational potential energy of elevation, and the kinetic energy of fluid motion remains constant. The theorem still forms the basis of many engineering applications such as aircraft wing design. He also established the basis for the kinetic theory of gases and heat by demonstrating that the impact of molecules on a surface would explain pressure, and that, assuming the constant random motion of molecules, pressure and motion increase with temperature.
Gottfried Wilhelm Leibniz. Leibniz was born on July 1, 1646 in Leipzig. Leibniz was a German philosopher, mathematician, scientist, diplomat, and polymath. As a philosopher, he was one of the greatest representatives of the 17th century rationalism. As a mathematician, his greatest achievement was the development of the main ideas of differential and integral calculus. Mathematical works have always favored Leibniz notation as the conventional expression of calculus. Inventing the Leibniz wheel, he was a pioneer in the field of mechanical calculator. He also refined the binary number system, which is the foundation of nearly all digital computers. Many people are saying that Leibniz have copied the idea of Newton in the development of calculus. But according to Leibniz, Newton worked on the method called the science of fluxions, which is just a rudimentary idea of differential calculus. Leibniz worked on both differential and integral calculus. And the symbols for differentiation dy over dx and integration fx dx are indeed his inventions. The name of the subject calculus is also created by Leibniz. Moreover, he worked on the differentiation of the product and the quotient of two functions. And he also proposed the fundamental theorem of calculus, formally establishing the inverse relationship between differentiation and integration.
According to Leibniz, the greatness of a life can only be estimated by the multitude of its actions. We should not count the years, it is our actions which constitute our life. Augustin Louis Cauchy. Cauchy was a French mathematician. He was famous for the countless contributions he made to the domain of mathematics. He made special contribution to mathematical analysis and the theory of substitution groups. For a brief period, he served as a military engineer for Napoleon's English invasion fleet. He wrote many books that cover a wide area of mathematics and mathematical physics. He authored around 800 research articles. His paper on definite integrals acted as the basis of the theory of complex functions. Due to his praiseworthy contribution to wave propagation, which is an important part of hydrodynamics, he received the prestigious Grand Prix from the Institute of France. His theories and functions of complex variables have played substantial part in subjects ranging from applied mathematics to aeronautics. His significant papers on aero theory act as a valuable asset for the domain of science. Fouché was the first mathematician who developed definitions and rules for mathematics. He introduced the definitions of the integral rules for series convergence, and as a person, he was a God-fearing, earnest Roman Catholic and a strict Bourbon royalist. He was active involved with Institut Catholique and École Normale Ecclésiastique. During the 18th century, mathematicians and physicists embraced mathematics in general, and the calculus in particular, as an increasing powerful set of analytic techniques useful in the description of the physical world. Advancements in the mathematical methods fueled increasingly detailed descriptions and investigations of the physical world. Caught between the rise of empirical science and the demands of the fledgling Industrial Revolution, the application of mathematics often outpaced its theoretical footing. Although there were sporadic attempts throughout the century to reconcile mathematical theory with its practical applications, it was mostly French school of mathematicians in the later half of the century that undertook the task of producing a rigorous, self-consistent mathematical system that was closely correlated to natural phenomena. The end result of these efforts to reintroduce the rigorous analysis provided the foundation, construction, and rise of pure mathematics during the 19th century. If you wanted to know more of our 18th century mathematicians, just visit www.famouspeople.com/18th century mathematicians. Thank you for watching. God bless, and to God be all the glory.